Extremely hot and insanely fast. Yeah, that's me. Oh wait, you mean the space thing. Okay, first, they discovered Peg 51, an exoplanet that orbits a star similar to ours. An exoplanet is any planet outside of our solar system that orbits a star that's not the Sun. This planet was completely different from anything we've ever found. Almost the same diameter as Jupiter, but half the gas giant's mass. It took only 4 days for this exoplanet to orbit its star, which seemed impossible. It was definitely too fast for something so massive. And then, scientists started finding something they've named hot Jupiters all over space. Lots of heated gas giants were located only a couple of million miles away from their stars. Sometimes, there were a couple of space bodies orbiting their stars pretty closely, and many were a few times bigger than Earth. Solar systems where they found hot Jupiters are not like ours. We have a neat system with smaller rocky planets on the inside and big gas giants on the outside. And almost all of them peacefully orbit the Sun, following their trajectories. Everything is in order. When a star is at the earliest stage of its formation, it creates a disk of gases, debris, and dust surrounding it. It's called an accretion disk. These gases slowly get pulled into the star because of its gravitational forces, and this leads to some kind of a stellar whirlpool. The outer parts of the disk are more gas-dense than the center. With time, the whirlpool effect gets even stronger. The same thing happens with hot Jupiters, which causes these gas giants to start orbiting much faster than usual. This also carries it further toward the star in a tightening spiral. Luckily, our Jupiter didn't become a hot Jupiter. Our gas giant started its life as an icy Earth-sized asteroid, which is different from the way hot Jupiters form. During the time when it was forming, Jupiter was around 4 times as far from the Sun as it is today, somewhere between Uranus and Neptune. About 2 to 3 million years after Jupiter first formed in the accretion disk of our Sun, it started a 700 million year long phase astronomers call the Grand Tack. Now, tack is something a boat performs when going towards a buoy and then slipping past and around it. Then it speeds up and goes in the direction where it came from. That was the same thing Jupiter started doing, and in its tightening orbital migrations, the planet's gravity could have moved many asteroids and other space bodies, distorted the orbits of larger planets, and caused collisions and chaos. Jupiter's Grand Tack would have destroyed many big space bodies. It's a could-have-been scenario, but luckily, Jupiter changed its course and became a peaceful gas giant. Neptune, Uranus, and Saturn were starting their own version of this chaotic process. Saturn even got so big that its gravity started pulling Jupiter away from its orbit. But after some time, these gas giants' orbits became locked. Then both of them managed to clear away the gases remaining between them. And since these gases were some sort of fuel for the planet's migrations, Jupiter and Saturn could both finally settle into the stable orbits we know today. Jupiter can still lob 1 to 2 icy asteroids at the inner planets from time to time. But when our planet was younger, this could have been one of the processes that formed the oceans on Earth. But Jupiter is much calmer these days. Saturn's gravitational forces have moderated the situation and are now keeping it under control. Now, Jupiter is our protector. It's 2.5 times the mass of the other planets of our solar system combined. It's some sort of a gravitational shield orbiting around the inner part of the solar system. Jupiter redirects incoming debris and asteroids away from the inner planets, Mercury, Venus, Earth, and Mars, keeping us all safe. Because of this, Earth has always been protected, so our planet has had enough time to evolve complex life forms. And it hasn't been destroyed by asteroids, hot Jupiters, or other space bodies. Jupiter wasn't the only planet that could have collided with Earth. Scientists think Mercury might have been involved in a hit-and-run accident with our planet. Mercury is the innermost planet in our solar system. It's the closest to the Sun and the smallest planet out there. And it also keeps getting smaller. Nowadays, its diameter is around 9 miles smaller compared to its size 4 billion years ago. Scientists think this might be happening because the planet's core is made of iron, and this iron is cooling and becoming solid, which is slowly reducing the planet's size. Mercury is the planet with the biggest number of craters in our solar system. Its atmosphere is really thin, so it can do nothing to keep the planet protected from meteors. The largest crater on Mercury's surface is at least 963 miles across. It could fit Western Europe from Germany to Portugal. The object that formed such a crater must have been at least 62 miles long. With all these craters, Mercury looks similar to our Moon. It orbits the Sun faster than the other planets, so 1 year on Mercury lasts around 88 Earth days. That means celebrating a birthday every 3 months or even more often. At the same time, the planet rotates so slowly that a day on Mercury lasts almost 59 Earth days, a long time to wait to go to bed. There's a piece of Mercury on our planet. In 2012, a green meteorite was found at a street market in Morocco. Scientists studied its composition and concluded it could be from Mercury. Mercury doesn't have its own moons because of its small size and weak gravity. Plus, the planet is too close to the Sun. By the way, the only other planet without moons in our solar system is Venus. Mercury has a really thin crust, like a good pizza. One of the theories of the planet's formation claims there was a major collision where the planet lost most of its crust. It could have also moved Mercury from its original spot. It wouldn't be unusual. The gas giants in our solar system also didn't form in the location where they are today. Mercury also has an eccentric orbit, which means it could have been kicked out of its old orbit and moved to a new one. Scientists also think Mercury might have collided with the early Earth. One theory says that's how the Moon could be formed. Out of all the material flying away after the big crash, there might even have been pieces of Mercury's crust in the mix. Exoplanets Kepler-107b and Kepler-107c are a pair of planets that orbit a star similar to our Sun in the Kepler-107 system. It's around 1,700 light-years away from us. These planets have almost identical sizes, both with a radius 1.5 times that of Earth. But one of them, Kepler-107c, is almost 3 times as dense as the other. That's because the planets have a different composition. Some scientists believe that Kepler-107b is less dense because it probably collided with another unknown planet in the past. This powerful hit took away part of its surface and left behind a very dense core rich in iron. A huge comet hit Neptune around 200 years ago. But since Neptune isn't a rocky planet with a thin atmosphere like Mars or Mercury, it's harder to find evidence of this impact. But a comet called Shoemaker-Levy 9 broke apart in 1994 and smashed into Jupiter. Astronomers managed to record this event. It helped them learn more about the elements and molecules the collisions left in Jupiter's atmosphere. This information helps scientists realize that the amount of carbon monoxide in the upper layers of Neptune's atmosphere is higher than in the lower ones. This means a big comet likely hit the planet in the past, since comets have carbon monoxide in their icy tails. Something huge slammed into Uranus, too, changing the planet forever. A space object twice bigger than Earth hit the ice giant. This left the planet tilted, and it looks as if it's rotating on its side. Uranus is extremely cold, way colder than it's supposed to be. It might mean that the object that slammed into it was probably a young protoplanet made up of ice and rocks. Also, some of the debris from that collision may have created a thin shell around Uranus. It still traps the heat coming from the core of the planet. There are strange energy pulses bombarding our entire galaxy, and they come from the other side of the universe. Over the last decade, scientists have been observing bizarre flashes of light coming toward our planet. This phenomenon is called fast radio bursts, or FRBs. These signals travel through a couple of billion light-years of dust and gas. That's a rather long way. So far, no one has figured out what's going on behind these bursts.